Thomas Young and Frost. The next theory was transverse nature of light. It was proposed by Thomas Young and Ernst electromagnetic theory. Proposed by Karl Maxwell. So again, corpuscular theory proposed by Newton, wave theory proposed by Huygens. So corpuscular theory, light travels in the form of tiny particles called corpuscles. In wave theory, light travels in the form of wave. But at the time of Huygens, he believed that light needs a medium for its propagation. And light travels in the form of longitudinal waves. After that only, light is not a longitudinal wave, light is a transverse wave. The nature of light wave is transverse. It was proposed by Thomas Young and Fresnel. Next, the electromagnetic wave, the wave which needs no medium for its propagation. As per wave theory, light needs a medium, but after that it was proved light needs no medium for its propagation. Light is a kind of electromagnetic wave. Clark Maxwell proposed electromagnetic theory. And the latest theory is the dual nature of light. The dual nature of light was proposed by Louis de Broglie. As per dual means double. Dual nature means light has both particle as well as wave nature. Light travels in the form of waves, but it contains small particles called photons. So dual nature says light has both particle and wave nature. So these are the main theories. The main theories which explains the nature of light. Corpuscular theory, next wave theory, next transverse nature of light, and after that electromagnetic theory, Clark Maxwell proposed it. So we got a complete idea about light after all these theories. And finally the dual nature of light, which explains light has both particle nature as well as wave nature. So based on all these one only, we can explain all these properties, and there are many other properties like diffraction, interference, dispersion, polarization. To explain all these properties, we are not studying all these properties. We study only few properties in school level. So reflection and refraction we study, again dispersion we study. So only these properties we are studying in this one. But like there are so many other properties. To explain all these properties, we require many theories. So these are the theories regarding light, and these are the different properties of light. So in this one, we study mainly about today reflection of light. Reflection of light. After studying this reflection, laws of reflection, we can go to the next topic. First, let us understand what is reflection. You imagine a wall. It is a wall. You imagine you throw a small rubber ball or elastic ball onto this wall like this. What happens? You throw one ball and you can see it hits at the wall and it comes back. It comes back. So here we throw a ball, it hits and it comes back. same way, when light strikes on certain surface, not all the surface, certain surface, that means smooth surface, like a mirror. So let us imagine this is a mirror. A very perfect smooth surface example is a mirror. Let us mark this is MM dash. So MM dash is a mirror and one light ray. So let us mark this one as PO. Incident at this point. You can see the light rays coming by to the same medium. So here, let us try this one as our normal medium, that is air. So this is also the same medium here. After striking a smooth surface, light rays come back. Let us draw a perpendicular at the point of incidence. Let us mark this one as OM. This one as OR. Here we can see PO. We can also see OR. We can also see the line ON. So what is here PO? So again once more, one light ray incidence at this mirror at this point O, and it comes back, it reflected back. Here OP is called, or PO is called the incident. OP or PO is called the incident ray and OR is called the reflected ray. Reflected ray. Then what is ON? ON is not a ray. Generally we say the incident ray, the reflected ray, and ON also by mistake we call ray, but ON is not a ray. ON is the perpendicular or normal. ON is the line what we do at this point of incidence. Here O is the point of incidence. You can see here again once more. What is PO? PO is the light ray which strikes on the smooth surface, and OR is the coming back or reflected ray. So first one is called the incident ray, second one is called the reflected ray, and ON is, don't call ON normal ray. ON is only the normal, and here O is the point of incidence. Here you can find two angles. The angle between, what is this? Normal. The angle between and what is OP? So whenever we define the angle is, it is an angle between something, angle between two lines. Angle here, what are the two lines? Angle between the normal and incident ray. This angle is called angle of incidence. Incident, not angle of incidence. What is I? Again, how can we define angle of incidence? It's very simple. All the angles are here measured with the normal. Angle between, it is an angle between incident ray and the normal is called the angle of incidence. And you can see another one angle this side between the normal and the reflected ray. This is called angle of reflection. So these are the important points regarding this reflection. Before going to the laws of reflection, we can see three lines here. two rays and one line here. One is OP. OP is the incident ray. One is OR. OR is the reflected ray, and another one is ON. ON is the normal drawn at the point of incidence. Normal at the point of incidence. Okay, let us see what are the laws of reflection. Laws of reflection. So the first one is incident ray, reflected ray, and the normal. Again, incident ray, reflected ray, and the normal. They lie on the same plane. So both are in the same medium. These three will be in the same plane. That is the first law. The incident ray, the normal, and the reflected ray lie on the same plane, and they are on either side of the normal. The incident ray, the normal, and the reflected ray are on either side of the normal. That we can define as the second law of reflection. And the third one is the most important and useful law regarding reflection of light. That is angle of reflection, angle of incidence is equal to angle of reflection. Angle of reflection. Angle of incidence, angle I, is equal to angle of reflection, that is angle R. This first law and second law not much useful in our case, but the third law is very useful to solve the problems and all. That is angle of incidence is equal to angle of reflection. So once more, reflection means the coming back of light rays after striking a smooth surface like mirror or any other soft surface like steel plate and all. After striking it comes back. The coming back of light rays is called reflection of light. In case of reflection of light, we can see there is incident ray, normal, and reflected ray. So again, we saw what is the laws of reflection. So this laws of reflection, first one is the incident ray, the reflected ray, and the normal lie on the same plane. That is the first law. The incident ray, reflected ray, and the normal lie on the same plane. And the second law is they are on either side of the normal. The incident ray and the reflected ray are on opposite side of the normal. They are on either side of the normal. And the third one is angle of incidence is equal to angle of reflection. So this picture you can see here, this is the mirror and this is refraction of light. So here we can see reflection of light by a mirror. This boy is collecting all the sun rays to this mirror. From this mirror, it is reflecting. Now, Some uses of this reflection we can see. Uses of mirrors we can see. So we use in our house mirrors to see our face, that is dressing mirror we use. So here all we use the properties of reflection of mirrors. If you go to a shop like a street shop, dressing shop, jewelry shop, and there will be large number of mirrors they are using to see all this one. So now let us, this reflection is actually a topic given in 8th class or 9th class. 6th class its introduction is there. Now 10th mainly we study the topic that is the second property of light, refraction of light. Refraction of light. So reflection again, once if we say what is reflection, when light rays strike on a smooth surface, it comes back to the original medium, that is called reflection. Then let us understand what is refraction of light. For the refraction of light, there are two different media. In reflection, light strike and comes back, both are in the same medium. But here it is when light rays travel from one medium to another medium. Let us consider the first medium as air and the second medium as water. Here, light rays travel from air to water. So what happens if there is no change of this light rays? Then we can see this dotted line. This is the direction of propagation of the light. If it is going straight, but actually what is found at this point of separation, this line indicates the surface of water or point of separation. So above this one is air and below this is water. And this is the point of separation of the medium, two media, air and water. So light rays travel in straight line we studied if there is no change. But actually, let us draw here also a normal at this point of incident. This is the line drawn, the normal. Here we can see light rays change its direction of propagation and it bend at this point of separation of these two medium. At this point of separation, it changes. This is the original direction of propagation, but we can see it moving towards the normal. It is bending towards the normal. If we mark this one as angle of incident, just like the previous case, the angle between the incident ray and the normal is called here also incident angle or angle of incidence. Angle of incidence. And here again you can see another one angle. This here this angle we can, what is this angle? The angle between the same and dash. Here the normal. And same we can mark this point as O, P, O, R. Same name what we gave previously. In case of reflection also we gave, but in case of reflection we can see it comes back to the original medium. Here it is not coming by, it is passing through the second medium. And but there is a change in its direction. There is a change in its direction. Or it is coming towards the normal. It is bending towards the normal. This is called refraction. This is called refraction. So what is refraction? When light rays travel from one medium to another medium, when light rays travel from one medium to another medium of different here two medium, when we consider the second medium also capable of allowing the light rays. For example, air and water. Such mediums are ready for the propagation of water. If you take a medium like wood or something, it cannot. So it is not called a medium for light. We discuss only two medium for light. That means the place or the path through which light can pass. That is only under our discussion. So when light rays travel from one medium to another medium, it bends at the point of separation of these two media. It may be either coming towards the normal or moving away the normal according to the optical densities of these two medium or refractive index of these two medium. We discuss it later, that property. Now what we are studying is how it is happening or what it is happening, when it is happening. So this bending of light rays at the point of separation of these two media is called refraction. Once more, when light ray travels from one medium to another medium of different optical density, it bends at the point of separation of the two media. The bending of light rays, when it travels from one medium to another medium, bending can be due to different reasons. But here, when it is traveling from one medium to another medium, that bending is called refraction. Why the light rays bend and travel? Because of it changes its velocity. The velocity of light ray changes. Why the velocity of light rays changing? Because of the change in density of these two media. The optical density or density of these two medium are not same. Because of that, its velocity changes. Velocity increases or velocity decreases. According to that, the light rays bend towards the normal or bend away from the normal. In this case, we can see air and water. The density of water is more than air. So in such a case, the velocity decreases. Velocity in water is less than, we can write velocity in water. Or for light, velocity in water is less than velocity in air. In this case, the velocity of water is less, so it bends towards the normal. Now here again we can mark these points we already marked just like previous cases. Here also we can find the two angles. Here also we can find the three. The normal is there. Previous case it is incident ray. Now also it is incident ray. Just comparing reflection and refraction we are comparing. It is always easy to compare and study what is reflection and what is refraction. Refraction means coming by of light rays. Refraction means bending of light rays at the point of separation. So whenever you are reading about refraction, once you can think about what is refraction, so the study will be very easy. So in such a case, refraction means coming back of light rays. Refraction means bending of light rays. So always try to compare and study. In this case, in the previous case, in case of refraction, angle of incidence is equal to angle of refraction. But here we can understand, from the picture we can understand, they are not equal. The angle of incidence and angle of refraction need not to be equal. Certain cases they will be equal also. That case we will discuss. I'll explain when they will be equal. But generally we can see because the two densities may not be same. So angle of incidence, that is now say not equal to angle of refraction. In most of the cases, there are, for example, if you take two glass, one is glass and another one is glycerin, we can see there will be no bending because almost they do have the same refractive index. Light will not bend and travel. That means angle of incidence and angle of refraction are equal. Only few cases. In most of the cases, they are not equal. So now in this case, let us consider this particular case study is from air to water. Light rays travel from air to water. When light rays travel from air to water, you can see here angle of incidence is greater than angle of refraction. This angle of incidence is more than angle of refraction, or angle of refraction is less than angle of incidence. That means the rays bend towards the normal, not bend away. There are two cases. One is bending away from the normal, one is bending towards the normal. Here the light ray bend towards the normal. Velocity decreases. In the second media, light travels with less velocity than in the first media, or the velocity of light in water is less than the velocity of light in air. Again, we can define here this terms. What is angle of incidence and what is angle of refraction? So angle of incidence. What is angle of incidence? Just like our previous case, angle of incidence is equal to the angle between the normal and the incident ray. Angle between the normal and the incident ray. And what is angle of refraction? What is angle of refraction? Angle of refraction is the angle between the normal and the refracted ray. This ray is called the refracted ray. So angle of refraction is previous case also we define the angle between normal and the incident ray or refracted ray. Here also we explain the angle between the normal and the refracted ray is angle of refraction, and angle between the incident ray and the normal is angle of incident. Angle of incident. And there is we can't say this is not a greater or less is not a law of refraction. Just in this case, I said there is a relation between angle of incidence and angle of refraction that we will discuss in our next class. Now, this is only in particular case we explained in this one. It is not a law of refraction. So there is a relation between angle of incidence and angle of refraction with respect to these two medium. That will come under laws of refraction. Now this is not the laws of refraction. Once more, we can define what is refraction. So what is refraction? If I ask, refraction is the bending of light rays. The bending of light rays when it travels from one medium to another medium. The light rays bend and travel at the point of separation of these two media. This is called refraction of light. So what is the reason for refraction of light? Because light rays changes its velocity due to the change in density of these two media. So because of that one, sometimes it is in this case, what is the medium? Air is called, so when the density is less than water, air is called the rarer medium. The medium with less density is called the rarer medium. In our example, it is the air. And water is called the denser medium. In this example, water is the denser medium. So optical density, not the mass density. When the optical density is less, the medium is called a rarer medium. And when the optical density is more, it is called a denser medium. So we can say when light travels from a rarer medium to denser medium, it comes to the normal. So again, laws of refraction we can explain in the next class. So today most important 2 points we studied. What is reflection and another one is what is refraction. So when you study this one, these two, please compare and study reflection and refraction. Have a nice day.
The class is testing. The class followed by maths and
already is that. There is screenshot.
good morning, children. Good morning, all of you. This is Nageshwara of Maths Faculty. Today, I'm going to explain you the continuation topic of basic maths. Yesterday, we discussed about number system and basic binary operations over integers and further topics. Yesterday we discussed. Today, I'm going to explain you major concepts where the students face while simplifying the sums, mainly in statistics, in coordinate geometry, in real numbers, in simplifying the sums. Students having many problems for simplification of the sums. Among them, the basic concept is LCM and its property, and fractions, additions, subtractions, multiplications and divisions. These concepts we are going to learn today, and the tips and tricks and how to solve them very easily we are going to learn. Okay, let us see. Basics of LCM. What is LCM? What is LCM? We are going to see. Before going to see the meaning of LCM and how we can do the procedure and how we can find the LCM values of a given data, let us give, one sum. What is the LCM of 7, 14, 28, 56? What is the LCM of 6, 12, 24 and 48? What is the LCM of 10, 20, 7, 14? See here, after completing this concept, after my explanation, easily you can say the LCM of 7, 14, 20 and 56 without doing without finding an LCM, you can find the answer. So for that, let us see LCM meaning, what is the concept, how we can do the procedure, what is the actual procedure for doing the LCM concept. Let us see. LCM means least common multiple. LCM means least common multiple. What is the meaning of LCM? LCM means least common multiple. I am explaining you what is the process of LCM. What is actually the LCM is. See here, we are going to find the LCM of 2, 3, 6. LCM of 2, 3, 6. First, let us write the two multiples. Multiples of 2. 2, 4, 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 5s are 10, 2 6s are 12, so on. Multiples of 2. Next, multiples of 3. 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6s are 18, so on. 6. So 6. Multiples of 6. Let us see once. 6, 12, 6 3s are 18, 6 4s are 24, 6 5s are 30, 6 6s are 36. For finding the LCM of 2, 3, 6, just we are finding the multiples. So let us see the common multiple of these. Common 6. 6 is the common multiple. 6 is the common multiple. 12. Multiple is the least multiple is 6. Among the common multiples, 6, 12, so on is there. Among them, the least multiple is 6. So this is the answer. This is the LCM of 2, 3, 6. So in this way, this is the actual method to find the LCM of 2, 3, 6. This is the actual method. And another method also there for finding the LCM of 2, 3, 6. This is one more method for finding the LCM of 2, 3, 6. This is another method. Prime factorization. 2 ones are 2. 2 ones are 2. 3 there. 2 3s are 6. 2 3s are 6. In 3 table, we have 3 ones are and 3 ones are. Enough, just you multiply these all values. 2 into 3 into 1 into 1 into 1 gives 6. So that is also another method of finding the LCM of given numbers. These two methods are very long process. Okay. First write down these two processes. Later I will tell you the shortcuts how to find the LCM of given numbers in a shortcut manner. You write down the two examples.